This is Dr. Ryan Johnson. This is Grace College Introduction to Statistics, Section 4.1. So today we're talking about confidence intervals. You should have already done the reading on this amazing dog named Marine, who apparently can smell colorectal cancer. And you should probably have learned about, so always look for the bold text, especially when you review this. So significance level. Our significance level is usually 5%, but it can be different from that sometimes. And um, and then you can do it many different significance levels. So hypothesized pi, and then remember thinking about two-sided p-value. You can do one-sided or two-sided. Confidence interval is one of the main terms you learned. Confidence level is the percentage that comes before. It's like a 95% confidence interval. It has a confidence level of 95%. So what our worksheet's going to do is going to do a lot of similar stuff to what you did in the reading. Okay, so let's switch from this really uplifting story of this dog to a really silly story. So the study that Section 4.1 is focused on is done by this German biopsychologist named Onur Gunturkun, who he and his research students went around and took notes on people kissing in public and whether or not they turned their heads right or left. You can you imagine? Anyway, Onur and his graduate students went around public places looking for people kissing in public, and went to see like if they were leaning right or leaning left, and took notes on it. And so let's dive in. So our first couple exercises are good review. So identify the observational units in this study, and then identify the variable recorded in the study, classified as categorical or quantitative. So remember, the observational units would be like the rows in the spreadsheet they made, and the variable would be the column in the spreadsheet they made. And then pi is going to denote the proportion of all kissing couples in the countries where the data is collected that lean their heads to the right. And so is pi a parameter or statistic? That's a review question. Explain how you're deciding. And then number 4, do we know the exact value of pi based on the observed data? That's a review question. Number 5, state the appropriate null and alternative hypothesis, both in words and in terms of the parameter pi, for testing the conjecture that kissing couples tend to lean their heads to the right more often by random chance. So more often than random chance would be, what proportion would you expect if it were random? If it were random, it'd be a certain proportion, and then use that number in your null and alternative hypothesis. Okay, number 6, calculate the sample proportion of the observed couples who lean their heads to the right while kissing. So let's look at, that's referring to this data that we're given. Of the 124 couples observed, 80 lean their heads to the right. So for this one, you need your handy dandy calculator, and you need to be doing, a number divided by a number. All right, so number 7, conduct a simulation analysis using the one proportion applet to assess the strength of evidence that the sample data provide for Gunturkun's conjecture that kissing couples tend to lean their head to the right more often than they would random chance. Okay, the one proportion applet. So if you're in Canvas, you can go up to student resources, applets. That takes you here. The one proportion applet's right there. Okay, so my probability is going to be 0.5, and I'm going to do 124 tosses. And if I'm doing some good analysis, at least 1,000, maybe 10,000, depends on how slow your computer is. If you do 10,000 for some computers, it could be kind of slow. And then definitely don't show the animation. Draw the samples. And so then we've got 80. We'll count that. And so, okay. And so this is going to be somewhat random. Mine might be a little different from yours. And so that's how you would do that. Okay. So make sure number 6 to use the correct symbol to note the value. Okay. Strength of evidence. So then once you've done this, you need to then, use what we've already learned about this sort of thing to summarize your strength of evidence. Like report the approximate p-value and summarize conclusion about the strength of evidence. That's what you're doing. Okay. So your simulation analysis should convince you that the sample data provide very strong evidence to believe that kissing couples lean their heads to the right more than half the time in the long run. This leads to a natural follow-up question. How much more than half the time? In other words, we've got strong evidence that the long-run proportion of kissing couples who lean their head to the right is greater than 1/2. But can we now estimate the value of that probability? Let's see. We can do this by testing different null values of the probability that a couple leans to the right. So now test whether data provide evidence of probability of a couple leans to the right while kissing is different from 0.6. So instead of 0.5, 0.6 would be right here. We would draw samples. Okay. And then maybe I'll still do number of successes as 80. So if the true proportion was 60%, then getting 80 has a p-value of 0.1766. So interpret it that. Remember, the p-value is assuming the null hypothesis is true, the probability of getting data this weird or this extreme. And so when it's really low, then it's like maybe our assumption wasn't good. And when it's not so low, then it could have happened. So report your change in the applet and record your p-value. So now let's pause. What kind of tests are we conducting if we want to determine whether the population parameter is different from a hypothesized value, a one-sided or a two-sided? And the answer is two-sided. So we want to start doing something like this, clicking the two-sided from now on. Okay. So the level of significance is a value used in a criterion for deciding how small a p-value needs to be to provide convincing evidence to reject the null hypothesis. So the most common value is 0.05, which is basically like 1/20th. And so if something happens like less than 1 out of 20 times, that's weird enough in most cases. Okay. So we'll consider the value parameter to be plausible if the two-sided p-value is larger than the level of significance. So that's how it works. Is the p-value for testing the null value of 0.6 less than 0.05? Can the value of 0.6 be rejected, or is the value of 0.6 plausible for the probability? And then plausible is a key word there. For the probability that a couple leans their head to the right while kissing. So for number 9, you should have gotten a value. That value of your p-value should not have been smaller than 0.05. So you do not reject the null hypothesis. So that means you don't reject it as, so that means 0.06 is then plausible for pi. All right, so number 10. Does this mean that you've proven's a key word there, that exactly 6% of kissing couples lean right? Why or why not? So then use the applet to test probability values given the following table. Each time change the probability of success to match the value you're testing. Everything else should stay the same. So this is going to be, you just got to do this a lot and record a lot of p-values. So then you're going to do things like 0.54 and then draw samples. And then you're going to then look at your p-value and then reject or plausible. And maybe like use an R or a P. And then 0.55 and then draw samples. There's a p-value, reject or plausible, and so on and so forth. So you just got to do this multiple times, fill out the whole table, all the way there, all the way there. Okay, now using a 0.05 significance level in result from the question 11, provide a list of plausible values of pi, the long-run proportion of kissing couples who lean their heads to the right. Okay, so for number 12, give me the list of numbers that are plausible. Okay, so this list of values should be an interval containing all values between two endpoints. So the interval of plausible values you found is also called a 95% confidence interval for pi. Why is it called 95%? Because we used the 5% cutoff. Okay? So notice that 95%, 5% add up to 100. That's by design. So confidence level is then 95% is called the confidence level. The 5% is called the significance level. Okay. So does your 95% confidence interval from question 12 include the value 0.5? Does it include the value 0.6? Explain how your answers relate to the significance test and p-values that you can calculate. So make sure that you are doing this part in this question. So explaining how your answers relate to the significance. Okay, now for number 14. For number 14, now suppose we were to use a significance level of 0.01 instead of 0.05 to decide whether or not to reject the corresponding null hypothesis for each listed value of pi. How would you expect the interval of plausible values to change? Wider, narrower, or no change? Explain your reasoning. A great way to explain your reasoning here is to just look at this table and make a different reject or plausible based on 0.01 instead of 0.005. Okay? So then for 15, implement the 0.01 significance level to determine plausible values for the population proportion of all kissing couples that lean their heads to the right. Hint, start with the null value listed in the table in question 11, though you may have to test more null values as well. So you might have to go further endpoints on those tables. Okay, report the interval of plausible values. So how confident are you about the interval of plausible values that you listed in question 15? So those plausible values, that confidence level should correspond to your significance level. Number 17, what is the primary difference between 95% confidence interval reported in question 12 and the 99% confidence interval reported in question 15? Which interval is wider? Is this consistent with what you predicted in question 14? So go ahead and answer those questions. Once you've done these number calculations, those questions shouldn't be too hard. 18. How would you expect a 90% confidence interval to compare to 95 and 99% confidence intervals? Explain. Okay, so your explanation should match the key idea. As the confidence level increases, the width of the confidence interval also increases. So when I want to be 99% confident, I have to have a really wide area to I have 99% confidence in here. But if I only need to be 90% confident, I can have a smaller thing because I'm 90% confidence in here. Okay, so then we have some paragraphs that are good for you to read to try to get that basically summarizes what we hope that you've learned in this worksheet. And that completes this video.